Alright, so in this video, we're going to use what we just learned about pulse sources, and we're going to go ahead and drive an RC network and kind of just show the RC charging behavior that we learned about. So let's go ahead and start with a resistor. I'm going to go ahead and rotate that, and a capacitor. I'll go ahead and put ground over here for my source, wherever I'm going to put that. I'm leaving a bunch of space for my source because the pulse statements get a little bit long. Let me go ahead and just connect this up, and then I'm gonna pick my R and my C value so that I get a 1 millisecond time constant. Okay, maybe not sure if I've talked about time constants yet. Let's see. Yeah, okay, so I talk about it. Yeah, okay, that's fine. So I have talked about the time constant. So let's go ahead and make this a 1 kilo ohm resistor, and this will be a 1 microfarad capacitor. So if I were to go ahead and multiply 1K by 1 micro, I would get my time constant, which is 1 millisecond. Okay, so we know that it should take about 5 time constants for our capacitor to fully charge. So let's label this net VC. And when we create our pulse source, let's just keep that in mind, that we are going to need to account for about 5 milliseconds that it's going to take for our capacitor to charge up so that we can see the behavior in this circuit. So we'll call this VS. And then let's go ahead and change my pulse. We're going to start at 0, so my capacitor is initially going to be discharged. Let's pulse up to 5 volts. Let's delay it by 1 millisecond. We'll make very fast rise and fall times like we did in the past. And then let's just let this be on for 1 second. So something very long, right? It's going to basically stay on for a really long time. I'm basically just setting it to where it's going to pulse up to 5 volts and just stay there for the duration of my simulation, because I'm saying I want it to be on for a full second. And we're going to run our transient simulation for much less than that. Let's run it for 10 milliseconds. Okay. We're ready to run this RC circuit. Let's hit run, and I will split up my windows like I've done in the past. And what I'm actually going to do is I'm going to split this plane. I'm going to click, you can right click if you have a mouse. I'm going to 2-finger click with my trackpad, and I'm going to hit add plot pane. So now I have 2 plot panes where I can add traces. So on the top one, let's add our source voltage, right? And I'm actually going to go ahead and do what I've been doing, but I'll just go to -1 and 6. So I can see my pulse. And then I want to see my capacitor voltage on the bottom pane. So I'm going to click on that pane, and then I come back over into my schematic window and click VC. And there it is. There's my capacitor charging up. The exponential behavior which we have derived, we can see it in LT Spice. Okay, and we know it takes about 5 time constants to get 99% of the way there. So let me click on my trace, and I can actually move my cursor and see how close it is after 5 time constants. So at 1 millisecond, we can see that's where I start charging up. I'm still at 0 volts. 6 milliseconds would be 5 time constants later. So let's go over to 6 milliseconds and see where it's at. And so right at 6 milliseconds, it's at 4.966 out of 5, which is about 99% of the way there. Okay, so we can see our RC circuit behavior exactly as we would expect it to be from hand calculations right here in LT Spice, which is pretty awesome. And it's really useful to use the pulse sources for doing what we've been talking about, which is, we want to start at some voltage, some low voltage where our circuit is initially in a discharged state, and then we pulse up by turning that source on, and then we just let it sit there until this capacitor is fully charged. Okay, so I'm going to go ahead and end this video. Just wanted to show a brief RC circuit example just to kind of put some simulation to what we've been learning about with the RC circuits in the lecture videos.